Okay, so has you ever stumbled on a research paper? It's like, whoa, this whole other world just opened up.
Hmm.
That's what we're doing today, diving into the world of black soldier flies.
I'm excited.
These little guys, they're incredible. And we've got 3 papers to dig into, all
Mm.
about how they can be used to, well, change the world, basically. Yeah, we're
Oh,
talking using them to deal with coffee waste, like how their diet affects what nutrients they produce.
right.
And get this, they even create a substance found in like soap and shampoo, everyday stuff.
No way.
Yeah. But first, let's talk about, well, trash. Specifically the coffee kind.
Hmm.
You know how much waste is produced just from making coffee? Like mountains of coffee pulp. And me, I love my coffee, so this is important.
Oh, absolutely. It's a huge issue. Coffee production, it generates a ton of this pulp, and if it's not disposed of properly, it can be really bad for the environment and ends up polluting water sources. It's a real problem.
So what can we do? Black soldier, fly larvae to the rescue. Our little, well, they're kind of wriggly, but they're our heroes.
It's true, these little guys are like nature's garbage disposals.
Right.
The first paper we're looking at today, it's called Efficiency of Bioconversion of Coffee Pulp Using Hermetia illucens, Diptera stratiomydae.
Gotcha.
And it found that these larvae can break down coffee pulp incredibly efficiently, like little nutrient vacuums, sucking up all the good stuff from the coffee pulp and leaving behind
Wow.
way less waste.
That's amazing. And they're not just chowing down on it randomly, right? The researchers, they actually experimented with different amounts of coffee pulp to see how it affected the larvae.
Exactly. They wanted to figure out the perfect amount, the sweet spot to get these larvae to break down as much waste as possible. It's like optimizing their diet for peak performance.
Like fine-tuning a race car.
Yeah, exactly.
So what do they find? What's the magic number?
Well, it wasn't just about how much they ate. It was also about, like, what were they going for? Speed or thoroughness?
Interesting.
So for the fastest development, a whopping 200 milligrams per larva per day got them to the pupa stage. That's the stage before they become an adult fly, in record time. Just 38 days.
Wow.
But feeding them a bit less, like around 100 milligrams, it was slower, but they ended up breaking down almost 63% of the waste.
So it's a trade-off. Faster, but maybe messier, or slower, but more thorough. It's like choosing between a slow cooker and a microwave, I guess. Both get the job done, just differently.
That's a good way to put it.
And this is something researchers are really grappling with, especially when we talk about using these larvae on a larger scale.
Yeah, it really shows how amazing these little creatures are, how adaptable they are.
Totally.
And that leads us to the second paper we're looking at today.
Okay.
Valorization of organic waste byproduct. This one really blew me away.
Really, I got to say, this title, it's a little less catchy than the last one, but all right, let's hear it.
Oh, trust me, the content is fascinating. They tested out like seven
Sorry.
yes, 7 different types of organic waste.
Like what? Give me
Yeah.
the dirt.
Okay, so we're talking fish trimmings, sugar beet pulp, the stuff left over from making sugar,
Uh,
bakery waste, even cheese waste.
Hold on, cheese waste. Was there like a wine and cheese pairing happening in the lab with these larvae?
No cheese plates for the larva, as tempting as that might be.
Okay, fine. Back to the science then. So, 7 different types of waste. What did they find out? Can these larvae handle all that?
They can. That's the amazing part. They found that black soldier fly larvae are just incredibly efficient at, well, think of it like this, bioconcentrating nutrients.
Okay, break that down for me. What does that even mean?
Basically, they pull in all the good stuff, the nutrients from whatever waste they're eating, and they pack it into their own little body.
Okay, so like they're little nutrient factories.
Exactly.
But you said the type of waste affects the nutrients, right?
Yeah.
So what they eat changes what they're like made of.
Yes, and this is where it gets even more interesting. They found that the larvae that were fed fish trimmings and brewer's grains, the stuff left over from making beer,
Okay, yeah.
those larvae, they were packed with protein and these really important essential fatty acids.
So wait, are you saying we could take food waste, feed it to these larvae, and then use the larvae to like create a sustainable food source for, I don't know, fish farms?
You're getting it.
We're talking about a closed loop here. That's incredible.
That's exactly what has researchers so excited about black soldier fly farming. It's this idea of a closed loop system, and it gets even cooler because by changing their diet, we can basically tweak what those larvae produce.
Wait, really?
Yeah. Need more protein, adjust the food. Need a different kind of fat, adjust it again. It's like we can program these larvae to create exactly what we need.
Okay, this is blowing my mind.
Hmm.
We've gone from trash-eating larvae to, like, custom-designed nutrient factories. What else can these little guys do?
Well, get ready for this one because the next study is maybe the most surprising yet.
Okay, all right, sound and spill it. What else can they do? Do they, like, predict the lottery numbers, too?
Uh-huh. Not quite, although that would be something.
Right.
This study, it's called, get this, lauric acid from the black soldier fly, Hermetia illucens, and its potential applications.
Okay.
It dives into a really fascinating byproduct of these larvae, lauric acid.
Lauric acid. Hold on. You mean like the stuff in my soap and shampoo? Are you serious?
Yeah.
These larvae make that.
Isn't that wild?
That's crazy.
Mm.
And it's not just, wait, it's another stuff too, right?
Oh, yeah, definitely. Food additives, some of them use it. It's really versatile.
Okay, back up a sec.
Yeah.
What makes this lauric acid so great? And why should we care that it's coming from, larvae?
Well, think of lauric acid as like the overachiever of the ingredient world.
Okay.
First of all, it's got these amazing antimicrobial properties, so it can actually help fight off bacteria and viruses.
Cool.
Imagine, like, cleaning products, but they're using this natural stuff. Pretty cool, huh?
Yeah.
And there's even research showing it might be able to help slow down the growth of certain cancer cells.
Seriously?
Yeah, it's a big deal.
Wow, that's incredible. But doesn't lauric acid, I thought that usually came from, like, coconuts? Or palm kernel oil, something like that?
You're right, it does, but getting it from those sources, it comes with a lot of baggage.
What do you mean?
Well, think about it. Deforestation, habitat loss, all that stuff, not so great.
So you're saying black soldier fly larvae, they could be a way to get it more sustainably.
Exactly. And ethically, too. It's not just about finding more, it's about finding a better way to get it. And the research is already showing that the lauric acid from black soldier fly larvae is just as good as the stuff we get from traditional sources.
Wow. This is huge. I mean, we've got these larvae, they're cleaning up our waste, turning it into food, and now they're producing a substance that could, like, revolutionize everything from cleaning products to cancer treatments. It's almost too good to be true,
Right.
Are there any downsides at all?
Well, you're right to be a little skeptical. Black soldier fly farming, it's still a pretty new thing. To really make a difference, to scale it up to meet global demand, we've got some challenges ahead.
Like what?
Well, for one, we need to figure out how to standardize farming practices.
What do you mean?
So making sure everyone's doing it the same way, that it's efficient and consistent no matter where you are in the world. It's like we need a black soldier fly larva farmer's almanac.
I buy that.
Right. A guide to best practices from breeding to harvesting, the whole 9 yards.
Yeah, totally. Makes sense.
And then there's the processing side of things. Figuring out how to extract that lauric acid efficiently, how to create a high-quality meal from the larva, and of course making sure it's all safe for people to use and eat. These are big challenges, but researchers and entrepreneurs, they're all working on it.
So it's just a matter of time.
I think so, yeah. Although we can't forget about, the ick factor. Convincing people to actually use insect-based products, whether it's the animal feed or the lauric acid in their soap, that might take some time.
That's true.
Education is key here. As people learn more about the environmental benefits, the ethical reasons to use these alternatives, I think we'll see a change.
It's about changing the narrative, right? These aren't just bugs. They're like tiny little superheroes helping us create a better future. And it's research like these studies we talked about today, that's what's going to get us there. It's amazing when you think about it. Something as small as a fly larva could hold the answers to some of our biggest problems. Who knew something that most people find kind of gross could actually be so important? It just goes to show that sometimes the best solutions are hiding in the most unexpected places.
I couldn't agree more.
If we can use these little larvae to create such valuable stuff, imagine what else is out there. What other weird and wonderful solutions are just waiting to be discovered? So keep asking those questions, stay curious, because you never know. You might stumble onto the next big thing. And that's it for today's deep dive. Until next time, keep exploring.